In addition to having the fraction a over b, meaning given a cats and b boxes, how many cats are there per box, we can also interpret a over b to mean if there are b slices of pizza with b equal size. How many do you have when you eat a slice? So, for instance, right here we have a picture of 1/3. But one thing we could do is we could cut each of the slices in half. So instead of 3 slices, now there are a total of 6 slices. So you see this bottom number ends up being the number of slices in the pizza, and then you see that there's still 2 shaded here. So the weird thing about this is that the bigger the number on the bottom, then, well, the slice size is smaller. Same deal over here. We have 3/4 represented, so 3 or 4 slices. And if we were to cut each slice exactly in half, so just adding in a new slice mark, not marking right along here right now, then there are 8 total slices and 6 of them are shaded in. Of course, this is not the only way we could have cut each existing slice into 3 equal sized smaller pieces. So instead of the original 4 of them, there are now, count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 10, 11, 12 slices are shaded. What you're seeing is the behavior that 1/3 is equal to 6, for instance. We have 3/4 is equal to our earlier fraction was 6/8, but we actually also have here currently in the picture 3/4 is equal to 12. The reason for doing things in this way is to talk about having the fraction a over b. This is equal to the same fraction in value if you take a over b and you multiply by the same thing on top and bottom. That same thing on top and bottom could be an s, or a z, or a c, or r, or whatever. But a over b is equal as a fraction to a times s over b times s. And we see that by example when we looked at how 1/3 was equal to 2/6. But we don't have to rely on this example. In fact, for an explanation, instead of writing down 1/3 equals 2/6 or even drawing this picture right here, we can avoid drawing this picture, or avoid drawing this picture right here by just saying something that kind of generically covers all of the cases all at once. And so the reason why this formula, a over b equals a times s over b times s, is true is you can say something like this. Here's the explanation. Eating a slices from a b slice pizza. Gotta be careful, there's 2 a's. This is the English word. Here's the number a. So eating a slices from a b slice pizza, I mean, pizza with b total slices, is the same amount of pizza as eating a times s slices from a b times s. So this is a generic explanation. It does not involve plugging in any numbers and true formula, with one exception. You don't want to plug in numbers. So instead of plugging in numbers and writing something like this, see, that just explains these two. But what we saw here was you start with 1/3, that would be our a over b, and multiply by s. In this case, 2 was our s, so each slice was cut into 2 pieces. In the next example, we started with 3/4, that was our a over b. And since each piece was cut into 3 smaller pieces, the s in that example was 3. But again, instead of drawing out this particular picture or writing down this, the point is that this explanation right here explains the formula in general. It really covers both of these stories at the same time. There's one last thing I want to say in this video regarding another formula, but this is getting messy, so let me clean up some of the space here. The thing that'll be relevant to this discussion is to keep these explanations right here. So I'd like to go back to looking at this formula. And again, here's the explanation that you can start with A over B and move forward into A times S over B times S, but you can also go backwards as is often in the formula. So if you started with A times S over B times S, then you can cancel the S's, draw the slash mark to these or not, doesn't matter to me, and you'll be left with A times B. We don't have A plus S over B plus S going A over B. That's a common mistake, but the reason why not is because, well, we haven't given any reason why you could cancel a plus S. See, the reason why we can cancel this times S is because we talked about going forward. Going forward here was to take the fraction A over B, and because of this reasoning we gave right here about the eating pizza slices and cutting slices into smaller pieces, we talked about how it's okay, it's a thing to start with the fraction A over B, and then to decide to multiply both the top and bottom by R or S, right, R. And so the reason that you can take the fraction A times R over B times R, the reason you can cancel the R's is you're undoing this whole multiplying by R. See, multiplying by R here, my video steps it, I'll just undo the multiplying by R. Right? So the point is, if you start with A times R over B R, see, this fraction, you could think of this fraction as having been obtained by taking this fraction right here and multiplying both the top and bottom by R. So the process of reversing this multiplying top and bottom by R is, well, you better have something times R. And so what you have to have is a common factor on top and bottom. So you see this times R right there, see that times R right there. Sorry, that's messy. And so because you have a times R, key thing is you have a factor, and then on the bottom you also have a times R. Here, you can now cancel those times out, be left with the fraction A over B. The key thing for canceling in fractions is you have to have multiplication. And again, the reason you have multiplication is we talked about right here. Multiplying by S on top and bottom is about taking your individual slices and cutting them each into S smaller sub-slices.